This is a podcast of Scripps Institution of Oceanography at University of California, San Diego. Ah, sea air. So fresh, so pure. But besides the sea salt particles that you can smell during a beach walk, a host of other marine aerosols, like organic matter, bacteria, viruses, and trace metals, escape the ocean every time bubbles pop at its surface. Some of these go on to become the infrastructure of clouds that form over the ocean. Since that activity covers the majority of Earth's surface, climate researchers have been very interested to understand this process better. At the University of California, San Diego, atmospheric chemistry professor Kim Prather and her colleagues at Scripps Institution of Oceanography are engaged in an interdisciplinary look at the mechanisms of ocean bubbling and aerosol release. Prather and members of her lab, including project scientist Hiroshi Furutani and graduate student Megan Moore, are conducting a series of controlled experiments as a first step.
Marine aerosols are particles that are produced by waves crashing in the ocean, and basically once a wave crashes it forms bubbles, and these bubbles rise to the surface and then burst, and this forms jets flying out of the ocean, and basically these droplets then evaporate and form or leave just the salt behind. And so what also occurs on the surface of the ocean is not just sea salt, but you have all sorts of organics from phytoplankton and different creatures in the ocean, and so these organics don't really mix with the water so well, so they end up on the surface. So when these bubbles burst, some of these organics can be incorporated into the bubbles that are bursting, and so when these particles dry up, they're not just salt, there's also some organics.
And so at the center of every cloud drop is a particle. And so when you're in a marine environment, most of those particles are sea spray, and so they can very strongly impact the clouds that form. Now, if you have microorganisms in the ocean, you have biological activity, you can start to see that the chemistry of the sea spray changes in the atmosphere, and that in turn affects the cloud formation that you get in areas of high biological activity. Since the ocean represents such a large fraction of the Earth, over 70% of the Earth is covered by the ocean, basically we figure that if we can sort of understand how those aerosols are behaving and affecting climate, potentially regional climate patterns, then we can start to understand the impact of a very, very large source of aerosols to our atmosphere on climate overall.
Basically what we do is we collect seawater, or we can make seawater in our lab. So basically we go down to the ocean, we collect this bunch in a jar, and we bubble air through this solution, and so we're making bubbles. And so when these bubbles burst, they can make particles in the air. So you have these particles, solid particles or liquid particles, basically like really small raindrops that are bursting in the air. And so what can happen is when these particles can lose some of their water and form solid salt droplets. So you can think of like the little salt crystals that you can barely see. These salt crystals can also have some kind of oil or organics that can come on the top of the ocean surface. So when the oil layer on top bursts, you can have some of this oil on these salt crystals. Later, when these salt crystals are in the air over the ocean, this water can go back on these salt crystals, and they can form large droplets, and these droplets can later come together and form clouds. So clouds are basically just a bunch of small droplets of water. And so each cloud droplet basically has one of these little crystals that started inside it. And if these crystals have a lot of organics associated with them, a lot of this oil, the oil and water don't mix, so this can affect their properties of taking up water and forming cloud droplets.
Prather and her team members say there is still a long way to go, but the payoff could come in the form of improved climate forecasting. Maybe, said Prather, the research could help scientists understand the human health impacts of marine aerosol release.
That's a big unknown, actually. I mean, basically, on the East Coast, they've been studied quite a bit due to the red tide toxin, which has been shown to be dispersed into the atmosphere and affecting people along the coast. But on the West Coast, it really hasn't been looked at. And so basically, it's a wide open area. We know that our bodies respond very strongly through an inflammation response to biological components such as mold. And so basically, similarly, there's a lot of biological components that are coming out of the ocean, and those could be having some effect, having respiratory effects as well. But the bottom line is the jury's really out. There has not really been a lot of research done in this area, but it's certainly something that I would say should be looked into at some point.
This is Robert Monroe for Scripps Institution of Oceanography at the University of California, San Diego.